Okay, let's go to the next question. The next question was given to us by Unarine Nemanguela. Unarine, I hope I say your name correct. Your question is beautiful. It's a long question, so I'm not even going to waste time. We're going to go straight into the question. They've given you the cubic equations function here, and the first question they ask you is to calculate f of 2, find f of 2, and the rest of the x-intercepts. So I'm suspecting that f of 2 is going to be a 0 because you need to factorize the cubic to find the x-intercepts. Now, before you can start factorizing, folks, you have to have one factor. So let's fall away and let's see what this gives us. If I calculate f of 2, I substitute all my x's with 2's, I get 8 minus 36 plus 2 times 24 is 48. Now already that's 56 minus this 56, and the result is 0. So if f of 2 is 0, it means we have a factor for this polynomial that they gave me. Now, I did a similar question last time I saw you guys when we solved the equation. So follow carefully. I'm going to do it slowly again so you understand. You do not need to know long division or synthetic division or any form of division other than what I'm going to show you now. If you've got the one root, you can find the other two quite easily. Look at this. We know that what's left here is a quadratic bracket. Why do we know that? Because the power is 3. So x times x squared will give me the x cubed. Now I've got a minus 2 here. This minus 2 multiplied by the constant at the end must give me minus 20. So if I take minus 2 and I multiply it with positive 10, I get minus 20. Now the big secret is, how do I find this middle term? I'm just going to call it bx for now. I'm leaving it there and we're solving for b. Okay, let's see our groupings. If I want to solve this b over here, I can work with these two terms because those are the two terms. If I multiply them out, that will give me an x squared. So I get bx times x is bx squared minus 2x squared must then be equal to the x squared term in the initial polynomial, 9x squared. So folks, now you can see that the x squareds actually don't matter. I just needed those coefficients to do the job for me. So what do I see? I see that b is equal to minus 9 plus 2, which is minus 7. Where does that b go into now? I go to the polynomial where I had the one root and I introduce the quadratic root, and I'm going to plug that in there. Let's have a look. If I go back with this 7 in there, then I get x minus 2 multiplied by x squared minus 7x plus 10. And look at this. All that's necessary now is to factor the quadratic. I have 2 roots for that. Hopefully, a 5 times 2 gives me 10, and a minus 5 minus a 2 gives me a minus 7. And look at what happened here again. I have x minus 2 squared times x minus 5. So that this is again a root of multiplicity 2. In other words, it's an x-intercept as well as a turning point of the graph. Okay, so let's formalize our answers. The x-intercepts will be at x equal to 2, x equal to 5. And this one, there's an or in between there. And this one is the root of multiplicity 2. Okay, let's go to the second part of this question. The 9.2 of Unarine's question is asking us to find the turning points of the graph. Now, folks, we already have one. The one turning point is at 2 and 0. It's the root of multiplicity 2. So we're going to be very lazy now. We are now going to differentiate and find the other one without a problem. Remember, at the turning points, the derivative of the function is indeed 0. Okay, so my function is at the top. Let me just carry on down here. My derivative of x here will be as follows. If I differentiate that, I get 3x squared minus 18x plus 24, which is 0. Now, folks, look at what I did. I differentiated this function that they gave me. 3x squared minus 18x plus 24. I make it equal to 0 because I'm in search of a turning point. But now here's where I'm going to be a little bit scallum. I know that one of those roots will be, or factors will be x minus 2. So let's do that. Let's make the one factor x minus 2. Well, what do I need here? I need a 3x so that if I multiply them out, I get 3x squared. I've got minus 2 here. All I need here is a plus 12 to give me the result of, it's a minus 12 rather, because the result is positive 24. Okay, let me just get my ink back. There we go. So the one turning point is at 2, and the other one, the x value here, is 3 divided by, or 12 divided by 3, which is 4. Now remember, I already have this turning point. To find the y value of that turning point, I need to go into the initial equation, not the derivative, the initial equation to find the y value. So let's go and see what is f of 4. Now, folks, that would mean everywhere in the initial polynomial, you are going to substitute the 4. Now, most of you guys do it with your calculator, so I'm just going to get the answer, and the answer for that will be negative 4. Okay, so my two turning points. So the turning points are at the point 2 and 0, the root of multiplicity 2, or there's another turning point at the point 4 and negative 4. Two turning points for this graph, expected because it's a cubic curve of which we had one root of multiplicity 2. Okay, let's continue with this question. The next part of the question is saying for us to sketch the graph on the diagram sheet that they provide. Now, we don't have a diagram sheet, so I'm going to try and sketch it as neatly as possible. So this is 9.3. I get my axes in order, my y-axis and my x-axis. Yeah, that's close to very, very accurate, my lines. Okay, so we have, what did we have? We had a turning point at 2 and 0. So that's the one turning point. The other turning point was here at 4 and, excuse me, at 4 and minus 4. And if you can remember, we found our other root. Our other root was at 5. So if I put my other x-intercept at 5, all I need now is my y-intercept. Now look at the initial equation. Remember, the constant in the equation is always the y-intercept of the function. So in this case, I need to indicate that as minus 20 on my graph. Remember, it says in the question, indicate all the turning points, all the intercepts with the axes as well. So let's go for it, that we can move to the next part of the question. I'm just going to hoy minus 20 down there. So here comes the function. It turns, it comes down, it turns again, and then it heads for the root at 5. And that is the graph of the function that I've been asked to sketch. Okay, so there can be a lot of questions they can ask you now. They can ask you for points of inflection. They can ask you where the graph is increasing or decreasing. There's quite a few things they can ask. Let's see what they asked on this actual question. They said, calculate the x values of the point of inflection. I knew that question was coming. It's always there. It comes in one of three forms. It either asks you to find the point of inflection or to find where the graph is concave downwards or where it's concave upwards. Now, folks, there's two ways to find the point of inflection. The first one is the easiest one. The first way to find the x value is just x is minus b over 3a. Okay, that's alternative number one. The second alternative, which is the one you most probably learned at school, is to find the second derivative and to make it equal to naught. So we'll do both of them. The second derivative of this is naught. Now remember, the b value is the coefficient of what is in front of x squared. So here I get minus 9, the b value was minus 9, over 3 times a, and a is 1. So we get 9 over 3, which is a. Did they ask for the coordinates? They say calculate the x values, in bracket, of the point of inflection. So there we have it. Please, folks, if they ask that, this is the quickest way to answer the question. And you can prove it by taking the second derivative of the general cubic and making it equal to naught. And you'll get your answer for x is minus b over 3a. It's very close to the axis of symmetry for the parabola as well. Okay, the alternative is the double derivative. So if I take my first derivative of the function, I get 3x squared minus 18x plus 24. The second derivative of that function is 6x minus 18, and I'm interested in where that is naught. So that happens at 18 divided by 3, which is x equal to 3. Okay, so you've got your x value for the point of inflection. Now they can ask you to interpret that answer if they feel like it, and they didn't in this particular question. One of the questions that's still coming, they did ask it. So let me deal with it now. If my point of inflection is here where x is 3, what happens when a graph passes through its point of inflection? Well, the graph goes from concave upwards to concave downwards. So the gradient is decreasing, 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 going through the point of inflection, and then it increases. Okay, so that's what the point of inflection indicates, where the gradient, where the curve changes its concavity. Remember that. Okay, the last part here on this question that Unarini gave us is the last part saying, find the values for which 9.5, for which x values is the derivative of this function positive. Now we already have the derivative, there it is. And you can see the derivative has a common factor of 3. So I'm going to go and divide the 3 away straight away. X squared minus 6x plus 8 has to be equal, or has to be bigger than naught. In fact, you know what, folks? You don't need this. Let's interpret it a different way, else we must draw diagrams. What does the derivative mean? Let's rather do the alternative. The derivative is, remember, a gradient. Okay? This means positive, bigger than naught. So when is the gradient positive? Overall, for any function that you work with, the gradient is positive where the function is increasing. Now, if we look at our graph here, our function is increasing here. It increases, there it's stationary, there it decreases, and there it increases again. So the result of this will be for x smaller than 2, or then for x bigger than 4. That's where the function will have a gradient that is indeed positive.